We just bought a new plate shear downstairs, came in over the summer. And it's a new system. It's electronically...
Direct drive motor.
Yeah, it's a direct drive motor. It's I forget, it's an EMP they call it. Anyways, it's non-hydraulic, no hydraulics in there whatsoever. It's just electric driven. It's supposed to be an energy saver because there's no hydraulic pumps running. When you turn on the power, it's just a little indicator light lets you know that power is supplied to the unit. However, trying to wire this piece of equipment up, we ran into issues because it was from overseas. Their their product literature wasn't all that great, and we tried 3 times, and 3 times it failed. The reason for that is when we put on a voltmeter on each line coming through 3-phase, at an instant draw, when you first call for electricity, it's pulling anywhere from 160 to 180 amps. Right? But only for a split peak second, and then tapers down to its operating of 20 amps or something like that. But in doing so, that much of a draw that quick was heating up our lines and tripping our breakers out, right? Because it's a shear, foot-operated shear that has 45 cycles per second, so it can chop 45 times. I mean, I'm sorry, per minute, 45 times per minute. And it was just something that they don't mention that. Peak power at all. It was just an operating power. I have 20 amps, and that's what we had powered it up to the first time. Started tripping breakers, couldn't figure it out, so we pulled the wires out, ran it a little bit larger, still popping breakers, and finally when I called the manufacturer finding out what was going on, we had to put a 100 amp breaker in, 100 amp wire.
Wow.
And it was just, we put an ammeter on there, and it was 160 to 180 amps on each leg, 3-phase power on each leg. But only for a split second.
Right. But see, now the utility knows that, and so if they're looking at your bill and all this stuff happens at the same time, you're going to add so much to the demand charge. Mm-hmm. And then you get into some buildings have these devices called smart panels, and they will only let so much power go through them. Right. And what they do is they lock out at particular if the panel starts sucking up so much power, it won't let anything turn on. It'll force it to wait. And so if you go to try to turn on a device like that and won't turn on, it means your smart panel is controlling it. And it may have to force you to wait 15 minutes before you can turn that next device on. And there's a lot of big buildings that have that. And so when people start to occupy offices, you might be able to only turn on one switch, but not both. You see a lot of this room has 2 light switches, and so each room will only get one switch on, and then they can turn the second one on in 15 minutes. But you can get down to some pretty aggressive control behaviors, especially with the smart panel.
But it's the old argument where upfront costs versus costs over time. People see the upfront costs all the time. You always see that. And this particular piece of machinery, it was a pretty reasonable price to buy it. So whereas a motor
that's what drove us to purchase it.
That's right. That's what drove us to purchase it, because the price was reasonable, but there wasn't really a lot of consideration given to the energy draw from this motor, whereas if you had a motor that was just driving a hydraulic pump that ran longer, it would probably use less energy, but now you have a hydraulic system also,
right?
To run the shear itself, to run the blade, so that machine probably is twice the cost of this one.
How
Right.
about playing with power factor? That's something a lot of big manufacturing places, you talk about, you get billed on your kilowatt hours, but it's really actually kilovolt amp hours.
Yep.
And if you ran purely resistive loads, it'd be one thing, but that's probably a big inductive rate. And some companies go as far as they have devices that will correct for power factor. Or you can actually, I think Kodak actually kept their lighting on in their parking lot to add a capacitive load to counteract the inductive loads.
Right.
To get the power factor back to 1.
Right. We, in one of the earlier classes, we talked about my neighbors who pay 2 to 3 times the electric bill that we do. And we got a device called the TED, which is the energy detective. And it's called a TED. And it goes onto the poles of your circuit breaker box. And we monitored their electric use for a month. And their kilowatts, based on their bill, were a little bit out of whack compared to what we were monitoring. And what we found out was that when we dove into the data a little more in depth, we found that their power factor was about, it was 0.75. Now, power goes through in a wave form. And so sometimes when you get things like motors and anything that kind of spins in that waveform, you can get the wave to get offset a little bit. And so when the power company sees that, they're filling this waveform. If the waveform is off, they have to actually make the waveform bigger to include it. And so they think you're drawing more power. But in fact, you're not. You're actually less. It's just that your power factor is off. And you want your power factor to all line up with the waves. And if it lines up perfectly, you have a power factor of 1, which is perfect. And that means you're paying for what you get. If your power factor starts to degrade and your waves get out of alignment, then you're paying for power you're not using, because you're not using any of this power. You're only using this power and this power. And so, in fact, you're paying for this, this, and this, even though you're not technically using it. So that's why we were able to see that the electric bill was different than what they were actually using and find out that you have a power factor. And they now make devices for homes. And so we're actually going to install one on these people's house and then see if it actually fixes the problem.
I mean, 0.75, that's pretty poor.
Oh, it's awful. It tripled their electric bill. We couldn't believe it. When we saw it, we thought there was a mistake. So
Like what I had mentioned earlier in the earlier classes was on a system like that, for your power factors, a lot of your surge protectors for your computers are not just surge spike protectors, they're also, they maintain that power factor
Right.
because of computer sensitivity. They won't allow that fluctuation. You had mentioned earlier today about possibly converting to DC. All right. Now I know under DC you can run a much higher amperage at a lower voltage,
right.
than would be under AC. I mean, wouldn't that just entail another inverter?
It didn't work very well for Thomas Edison.
So the solar array that we're installing at the high school is going to be made of rectangles, not these shapes. It produces power in DC, and what we have to do is run it through, which is direct current. We have to run it through an inverter and convert it over to AC so that the building can then use it. And the power that comes off the grid comes off in AC as well. DC, like you said, you get different voltages and amps. And does anybody know anybody whose house is off the grid? Completely disconnected from the grid? A lot of people who are disconnected from the grid use solar and huge battery banks to keep the electricity stored at night. Now what you find in their house is the major equipment in their house is DC. And so they may have a DC refrigerator and a DC HVAC system or something like that, and that they then have off the batteries, they have an inverter for the other kind of standard AC equipment. I know a lot of people who have. The number one thing seems to be DC refrigerators. And so that refrigerators are operating on a direct current, which is a little bit more efficient, particularly when you're trying to store and make your own electricity.
Well, wouldn't they be more expensive than though? Because it's a little...
You mean the DC refrigerators?
Yeah.
Yeah, they're a heck of a lot more expensive.
Yeah.
Some people are very serious about not being on the grid. They don't want to be. They're the same people that don't want you to know where they live. You know, a lot of people just, and then some people just really don't like how the utilities run and everything like that, and they just don't want to be a part of it.